Hello, Math 2 Plus. It's Miss Scott back for another lovely day of math. Before we jump into lesson 9-9, let's go ahead and do a quick warm up from our last lesson, 9-8. Feel free to hit pause and hit play when you're ready to check it out. So we're trying to determine the area of a triangle, and while we're used to 1/2 base times height, and I do have a lovely base here, I am missing the height. But don't panic. You guys remember that you can find the area of a triangle as long as you've got two sides and the angle in between. We're still going to do 1/2 times the base, but now we're going to multiply it by our other side times the sine of that angle in between, just like I have here. So this means that I'm going to grab a calculator. Please make sure that your calculator is in degrees. You will get a funky answer if it's not. Another really common mistake students make is they forget the 1/2. It's like you've done all the hard stuff and multiplied all the nasty bits, and then you just forget to cut it in half. So make sure you do that. Remember that this is area of a triangle, which means I am doing millimeters times millimeters. So I'm actually getting an answer that is millimeters squared. Nicely done. So up to this point, for the last week and a half, we've been playing with trigonometric functions, sine, cosine, tangent, all that fun stuff, our lovely little SOHCAHTOA to help us remember it all. But typically, we've been using it for right triangles. But it was kind of nice on the last lesson where it didn't have to be a right triangle and we could still use sine. Let's go ahead and expand on that and push it just a little bit further. Remember last time we had this issue that we didn't have the height, and so we use sine to help us figure out what the height is. I'd like you to go ahead and take a moment to find the sine of angle A, then solve for H, then find the sine of angle C and solve for H. Hit pause and then hit play when you're ready to keep going. So don't forget that the sine ratio is the opposite leg over the hypotenuse. And that means in the case of angle A, the sine of angle A should be equal to the length of H over the length of C. And it does say to solve for H, so let's go ahead and multiply both sides by C to get that guy all alone. And then we'll do the same thing for angle C. Again, opposite leg over the hypotenuse means it will still be an H on top, but in this case, my hypotenuse is actually A. Again, solve for H, we'll multiply both sides by A. And take a look at this. Both of these equal angle H. And if you remember from the last lesson, if two things equal the same thing, then they equal each other. Thanks, transitive property. Let's go ahead and gather all of our A's on one side and all of our C's on the other. So I'm going to divide both sides by A and divide both sides by C. And you get something that looks kind of like this. So sine of angle A over side A actually equals the sine of angle C over side C. This is what we call the law of sines. So the law of sines is cool because you can use it to determine all kinds of unknown measures in triangles, and they don't have to be right triangles. The coolest part is that, of course, it works all the way around. The sine of any angle should go over, make a nice little ratio with the side across from it. And then we can set up proportions all the way around. The best part about this is all you really need is two of these, because you guys know that you can cross multiply to find pieces that you're missing. The trick is remembering it's always the sine of the angle over the side across from it. Now that you know the law of sines, let's see if you can use it. Go ahead and try this out. Hit play when you're ready to keep going. So for me personally, it's hard for me to see what's going on here. I have so many letters and I've got all my numbers up the top. I'm gonna write my numbers onto my problem. And yes, it's gonna be sketchy because my handwriting with my mouse, oh, that's a lovely 64. So we are told the measure of angle A is 64 degrees. We are told the measure of angle B is 98 degrees. Oh dear, this is why Miss Scott's not an art major. And the side A is 29 miles. I'm going to put that over here. And I know you guys, as soon as you see it, you know where you're going with this. A and that 64 degrees and that 29 miles, they match up. So let's go ahead and use that for one of our ratios. The sine of 64 degrees over 29 miles. And I want to find little side B, which is convenient because I do know angle B across from it. So my other side will be the sine of 98 degrees over B. And you guys totally know how to solve proportions. Just cross multiply. Sine of 64 degrees times B should equal 29 times the sine of 98 degrees. I am trying to solve for B, so before I even reach for that calculator, I'm going to go ahead and divide by the sine of 64 degrees to get B all alone. And yes, at this point, I'm grabbing a calculator. Please be careful. Remember that you do not want to round early. That's not good for anybody. Make sure you keep things in your calculator as best you can before giving me your final answer. And of course, don't forget your units. This side was in miles, so I'm going to presume this side is in miles as well. And there it is, 31.951 miles. Not too bad, right? So you know I'm going to mess with you a little bit. Try this one. Again, hit pause and hit play when you're ready to keep going. So for this one, once again, I know angle A and I know the side across from it. So I'm totally going to use that. Sine of 51 degrees over 18. In this case, though, it's a little bit different because I don't know the angle, but I do know the side across from it. But the setup is still the same. Sine of angle B should go over 22 degrees. Now, normally I would cross multiply, but I'm lazy. And the truth is, it's sine B that I'm trying to get alone. So I'm just going to multiply 22 onto the other side. I also have a really little issue on this one, but an annoying one. Remember, I'm trying to find an angle. You guys know how to get rid of sine and find an angle. Just use inverse sine. Please be careful in putting this in the calculator. If you have one of my janky little calculators, you know you got to be careful. Sine of 51 degrees times the 22, divide it by the 18, and then hit shift or second to get your inverse sine going on. Please also remember that you are finding an angle. Your answer is not going to be in centimeters, but in degrees. Looking good? Okay, let's step it up a notch. Let's solve the entire triangle. Everything, all the angles, all the sides. Hit pause and then hit play when you're ready to check it out. So in this case, I only have one set that matches up. I've got 99 degrees over 4.7. I am totally going to use that. But before I even do that, let's find the easiest thing here. You guys know all the angles in a triangle add up to 180 degrees. So fine, let's use that to find angle B, which is 36 degrees. That makes things a heck of a lot easier. And again, you might want to write it in. You don't have to, but I like to. There we go. Now you've got all your angles, time to find your sides. So again, the staple that I choose to go with is this C guy right here, because I've got 99 degrees, so I know the sine of 99 should go over 4.7. And let's just take it one at a time. Nobody's telling you have to do everything all at once. So fine, sine of 99 over 4.7. Let's go with angle A. Should equal the sine of 45 degrees over the side across from it, which I don't know, so we'll just call it BC for now. And I'll cross multiply. And again, I need to get BC all alone, so I'm going to divide by the sine of 99 degrees. And then I'm going to grab a calculator. Don't forget your units. Let's now do this all over again, still using C and the guy across from him to help us find angle B. I know the sine of 36 degrees should go over the side I don't know, AC, and that should equal the sine of 99 degrees over 4.7. At this point, I'm going to cross multiply. I'm going to divide by the sine of 99 in order to get AC all alone on his own. And I'm going to grab a calculator. Don't forget the units. Fabulous work. So this is why the law of sines is pretty cool. We literally found everything that was missing on this triangle just by using the law of sines. It's pretty snazzy. It's pretty useful. Feel free to knock yourself out with it. Don't forget to write me a nice little summary